Okay, so we're going to have a look at the National 5 2019 Paper 1, going through all of it just in real time. Okay, so question 1. F of x is equal to 5x cubed. Evaluate f of negative 2 for 2 marks. So f of x is equal to 5x cubed. So f of negative 2 is going to be 5 times negative 2 cubed. So 2 cubed would be 2 times 2 times 2, which is 8. Negative 2 cubed is going to be negative 8, because we've got an odd power. So what we get there is that f of negative 2 is 5 times negative 8. So f of negative 2 is negative 40. Question 2. Evaluate 3/8 multiplied by 1 and 5/7, giving your answer in its simplest form. So we've got 3 over 8 times 1 and 5/7. Now I prefer to work in top-heavy fractions for this, so 7 times 1, then we add on to the 5, so we get 7 plus 5 is 12. So that's really 3 over 8 times 12 over 7. Now we're going to do a little bit of cancelling to make this a little bit easier for us. There are 2 4s in 8 and 3 4s in 12. So cancelling that down just makes that slightly easier. And that gives us then 3 times 3, which is 9 on the top, and 2 times 7, which is 14 on the bottom. And looking at that, there isn't anything there that we can cancel, so that's us done. Expand and simplify. We've got x plus 5 in the first bracket, and 2x squared minus 7x minus 3 in the second bracket. So each term in the second bracket is going to get multiplied by the x, and then each term in the second bracket is going to get multiplied by this positive 5. So we need to be aware of how negatives will affect this. So we get 2x cubed minus 7x squared minus 3x. And then from our green arcs here on the 5s, we get plus 10x squared. 5 times 7 is 35, so minus 35x. And 5 times negative 3 is negative 15. The marking scheme for these is normally any 3 correct, then all 6 correct, and then the third mark is for the correct simplification. So we get our 2x cubed, we've got minus 7x squared plus 10x squared, so we get plus 3x squared. Minus 3x minus 35x is minus 38x, and minus 15 there. So there's our third mark. Diagram below shows the sector of a circle, center C. The radius of the circle is 30 centimeters. Calculate the length of the major arc AB, taking pi to be 3.14. So we've been given a value for pi to make things a little bit easier on us. Let's get started. So the length of the major arc, well, our formula, x over 360, is equal to the arc over pi d, our circumference. The portion of the circle is equal to the portion of the arc. So we get that 240 over 360 is equal to our arc that we want over 3.14 multiplied by our diameter. So if the radius is 30 centimeters, then the diameter d is 60 centimeters times 60. So if we rearrange that, I'm going to throw this stuff up to the top that way. And I'm just going to swap the sides around so we get arc on this side. We get that the arc is equal to 314 times 60 times 240 all over 360. Now there's a little bit of cancelling we can do here. So I'm going to knock out the 60 and the 360 here. There is 160 in 60, and there are 6 of them in 360. Then we can do a little bit more with that. There is 1 6 in 6, and there are 40 of them in 240. And that makes this slightly easier for us. So we've got 3.14 multiplied by 40. So our arc is going to be 3.14 times 40 is 31.4 times 4. So 4 4s are 16, carry the 1, decimal point. 4 times 1 is 4, plus 1 is 5, and 4 times 3 is 12. 125.6, and our units are centimeters. Since this is the arc, it's just a length, so it's just centimeters. That's our final answer. Remember, you can show any working that you need to. This is the non-calculator paper. Question 5. The midday temperatures in Grantford are recorded over a 9-day period. The temperatures in degrees Celsius were 4, 7, 4, 3, 6, 10, 9, 5, and 3. Calculate the median and the semi-interquartile range of these temperatures. So for both of these, we're actually going to need this list in order. So let's reorganize the list. We've got 3 and 3, and then 4 and 4. We've got a 5, 6, and a 7. And then a 9 and a 10. Double check, we should have 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers there. Now the median is the middle number of an ordered list, so there's our median. Our median is 5 degrees Celsius. Our semi-interquartile range for these, so our interquartiles, or our quartiles, sorry, are going to be the middle of each of this upper and lower. So the middle of there and the middle of there. So we get, what's that, 3.5 and 8. So our semi-interquartile range is going to be 8 minus 3.5, which is 4.5 degrees Celsius. And I almost wrote 5 there. 4.5 degrees Celsius. Okay. Over the same 9-day period, the midday temperatures in Endok were also recorded. The median temperature was 8 degrees, and the semi-interquartile range was 1.5 degrees. Make 2 valid comparisons to the midday temperatures of Grantford and Endok. So we could say then that looking at the median, that the average temperature in Endok was higher. Endok was higher. And the interquartile range is lower there, so it means that the temperatures are actually more consistent. So the average temperature, no, sorry, the temperatures in Endok were more consistent. Okay, it means that the temperatures were all a lot similar to one another. Okay. There's our 2 comparisons. Let's carry on. The fuel consumption of a group of cars is recorded. The scatter graph shows the relationship between the fuel consumption, F kilometers per liter, and the engine size, E liters of the cars. A line of best fit has been drawn. Find the equation of the line of best fit in terms of F and E, giving the equation in its simplest form. Okay, so if we have a look, we've actually got 2 coordinates here. We've got the coordinate 1.514 and the coordinate down here, this one, which is 3.5, 8. With those 2 coordinates, we can calculate the gradient. So m equals y2 minus y1 over x2 minus x1. Obviously, we're not working in x's and y's, but y is the vertical, in this case the f, and x is the horizontal, in this case the e. So our gradient then is going to be, where's our, so we get 14 minus 8 over, oh, sorry, I've got that the wrong way around, because it's the 2's. So 8 minus 14 over 3.5 minus 1.5, which is negative 6 over 2, which is negative 3. So now we have our gradient. We have 2 points, so and no point of intersection, so we're going to use y minus b equals mx minus a. Now obviously we can swap in our other letters, so we've actually got f, and for a and b I'm going to use this one, a and b, just because I want to. So f minus 8 equals negative 3e minus 3.5. Now I'm going to move this down slightly so I'm not writing over that double line over there. Let's carry on. So rearranging this in terms of f and e in its simplest form. So we're going to break the bracket and take this 8 over to the other side. We get f is equal to negative 3e plus 3 times 3.5 is 10.5. And then we're adding on the 8 plus 8. So we get that f is equal to 18.5 minus 3e. A Mars car has an engine size of 1.1 liters. Use your equation from A to estimate how many kilometers per liter he should expect to get. So remembering the fuel consumption, kilometers per liter is F. We've been told his engine size, so that's the E. So what we get then is that F is equal to 18.5 minus 3 times 1.1. So his kilometers per liter is going to be 18.5 minus 3.3, which gives us a delightful 15.2 kilometers per liter. Okay, the area of a trapezium is given by the formula a half h x plus y. Make x the subject of this formula. It's a really handy formula if you can memorize it, but it is very specific. All right, so we want x to be the subject of the formula, which means we're going to have to break it out of those brackets. So to start with, I'm going to flip it around so that I've got a half h x plus y is equal to a, just to keep my x on the left-hand side. Now I'm going to get rid of the half by multiplying by 2, so I get that h x plus y is equal to 2a, just by doubling everything by 2. Now I'm going to divide through by the h, so I get that x plus y is equal to 2a over h. And then I need to subtract that y, so I get that x is equal to 2a over h minus y. And now x is subject to my formula, and everything else is off to the right-hand side. Okay. Simultaneous equations. John bought 7 bags of cement and 3 bags of gravel. The total weight of these bags is 215 kilograms. Write down an equation to illustrate this information. So to start with, I'm going to say let C be the weight of 1 bag of cement. Setting up my variables here. Let G be the weight of 1 bag of gravel. Write down an equation to illustrate this information. So 7 bags of cement plus 3 bags of gravel was 215 kilograms. Shona bought 5 bags of cement and 4 bags of gravel, with a total weight of her bags being 200 kilograms. So she has her 5 C's and her 4 G's, and that is 200 kilograms. Calculate the weight of 1 bag of cement and the weight of 1 bag of gravel. Here is our simultaneous equation part. I'm going to steal these equations from earlier, and we're going to use these to solve for G and C. So I'm going to call this equation 1 and this equation 2. Now I'm going to solve through elimination, just because I find it easier than substitution, especially in a question like this. Now, the lowest common multiple of 7 and 5 is 35, and the lowest common multiple of 3 and 4 is 12. So I'm going to eliminate the g's first, because 12 is an easier number to get to. So I'm going to take equation 1, and I'm going to multiply it by 4 to get 28c plus 12g is equal to 860. I'm going to call that equation 3. Then I'm going to take equation 2 and I'm going to multiply it by 3. And that's going to give me that 15c plus 12g is equal to 600. I'll call that equation 4. Now, since the signs in front of these 12g's are the same, it means I'm going to have to do a subtraction. So I look at the other number and check which one's bigger. 28 is bigger than 15, so I'm going to say equation 3, take away equation 4. So I get 28c's, take away 15c's, and that's 13c. 12g, take away 12g, is 0g. I'm going to write it down here just for completion. And 860 minus 600 is 260. So I get that 13c is 260. 13 doubled is 26. So 13c, there we go. So c is going to be 260 divided by 13, which is 20. Now I'm going to try and keep all of that on the page at the same time. So I'm going to work over here. Now we've got c is equal to 20. So c equals 20 in equation 1. Okay. Now we go back and we say then that 7 times 20 plus 3g's is 215. So 7 times 20, 7 times 2 is 14, so 7 times 20 is 140, plus 3g is 215. Take 140 away, gives us that 3g is equal to, what would that be, 175? No, sorry, just 75. 75. So if 3g is 75, then g is going to be 75 divided by 3, which is 25. So now we know what c is and we know what g is, but we need to check our work just to make sure. So we're going to check using equation 2. We used equation 1 to find g. We made 3 and 4 up ourselves. So we used equation 2 that came from one of our earlier questions. So check using equation 2. We've got 5 times 20 plus 4 times 25 is equal to 200. 5 20s is 100 plus 4 25s, which is 100, equals 200. So we know that's correct. And since we know that that's right, we can say 1 bag of cement. And we should use our words to answer it. Since it's a wordy question, it deserves a wordy answer. 1 bag of cement is 20 kilograms. 1 bag of gravel is 25 kilograms. Now they can be quite mean on the marking scheme. Some years C equals 20, G equals 25 would get you the final marks. But most often you need to have this wordy answer at the end. You need to state what the weight of a bag of cement is and what the weight of a bag of gravel is. Gravel has an L. Because the question asked 1 bag of cement, 1 bag of gravel. Okay? Moving on. Question 9, the graph shows a parabola. The maximum turning point has a coordinate of 420, as shown in the diagram. Write down the equation of the axis of symmetry of the graph. Well, the axis of symmetry passes through this point here at the turning point, there, and that gives us our x-coordinate already, so our equation is x equals 4. If you just write down 4, you will not get the mark, because 4 is not an equation. X equals 4 is an equation and gets you the mark. Okay, the equation of the parabola is of the form y equals b minus x plus a all squared. State the values of a and b. Well, typically, if we had a completed square parabola, that would be y equals x plus a squared plus b, and our turning point would be at negative a comma b. So with that in mind, we can then say that a is going to be, so that we're going to take that 4, we're going to say a equals negative 4, and b equals 20. Using our knowledge of the turning points. Seeing that they're only worth 1 mark, there is no working to do here. If you come across a question like this, you're either going to know it or you're not. It all depends on whether or not you remember the completed square form for these. Okay. Vectors. So in the triangle PQR, the vector PR is 6, negative 4, and the vector QR is negative 1, 8. Express PQ in component form. So We know PR, and we know RQ, so they're already nose to tail for us. And we want PQ. That's handy, we can just add them together. So the vector PQ is going to be PR plus RQ. Just adding those two together, nose to tail. Which gives us then, I've not left myself a lot of room, so I'm just going to add these together this way. 6, -4, plus -1, and plus 8. Close that bracket off, giving us the component form 5, 4. And we can just double check that. Yep, it's going across positively and it's going up positively, so 5, 4 makes sense. M is the midpoint of PR. Yeah, we can see that. Express MQ in component form. Ooh, MQ is going halfway along PR and then up to Q. So what we could do, if we take that as, how could we get to there? We could okay, so what we could do, oh, I think I've crashed the computer. One moment. And we're back. So what I could do then is go from here. I'm just trying to think of a nice way to do this that won't be messy. Oh yeah, that would work. So from okay, so the way we're going to do this, we're going to have a look at a half PR, and then we're going to add on PQ to that. Okay, and that will give us our vector for MQ. So we're going to have a half, oh, that's better. We're going to have a half PR, and to that we're going to add PQ. Okay, so we're going to go halfway along PR, and then we're going to use our vector from earlier from PQ, which gives us then, so PR was, so we want a half of 6 and a half of -4. And to that we're going to add on PQ, which is 5, 4, giving us 3 plus 5 is 8, and -4 halved is -2, plus 4 is 2. 8, 2 there. I'm not sure about that one. That's it. I've gone the wrong way. I've gone the wrong direction. Being silly, instead of PR, we want to go RP. RP, which means that this is negative and that's positive. There we go. Sorry about that. So, half of -6 is -3, plus 8 is, plus 5 is 2, and a half of 4 is 2, plus 4 is 6. There we go. So we're going from RP, so halfway RP. So we're going to there, and then we're adding on that PQ motion. Okay, so by doing that, we're going there and then there, and that gives us MQ. There we go. Now, don't forget to make sure that your brackets are the right size all the way over. Vectors can be a tricky one. It's all about whether or not you can visualize it. All right, carry on. Pam is designing a company logo. She starts by drawing a regular pentagon, A, B, C, D, E. The vertices of the pentagon lie on the circumference of the circle with center O. So here's our circle with center O, A, B, C, D, E. Okay. She then adds to the design as shown. Oh, she's added on a wee kite onto the bottom there. AF is the diameter of the circle. Calculate the size of the angle OFB. OFB. So that's this one in here. Okay, so let's see. What information do we already know? All right, well, if it's a pentagon, then that's going to be 72 degrees because 360 divided by 5 is 72. Since that's a straight line, this has to add up to 180, which gives us that that is 108 degrees in there. And since that and that are the same length, this is an isosceles triangle, which means that OFB and BOBF must be the same, and together plus 108, they have to add up to 180. So they're going to be half of 72, which makes them 36 degrees each. Okay, so we should state that then. OFB equals 36 degrees. Now, if you annotate your drawing there, that should be enough to get all of the working. And I apologize for the bell that's ringing in the background there. We are recording in a school. Okay. Question 12. Express root 2 over root 40 as a fraction with a rational denominator, giving your answer in its simplest form. Okay, so let's have a little bit of a play about with this. So root 2 over root 40, well, that's the same as the square root of 2 over 40, which is the same as the square root of 1 over 20. Now, with that in mind, that's the square root of 1 over the square root of 4 times 5, which is 1 over 2 root 5. Multiply top and bottom by root 5 over root 5, like that. And that will give us root 5 over 2 times 5, which is 10. Ta-da! I'll move that down slightly. Okay. Question 13. Part of the graph y equals 3 cos x plus 45 is shown in the diagram. The graph has a minimum turning point at A. State the coordinates of A. Well, a typical cos graph starts high, dips low, comes high again, and that happens there at 180, and typically at -1. Now this 3 means that our minimum turning point here is now going to happen at -3, since our maximum will be at 3. And this plus 45 means that everything is shifted that way 45 degrees. Okay, so what we actually have in fact is not 180, but 135 for our x-coordinate. So we get 135. And our y-coordinate is down to -3. So A is that coordinate. Remember, when we add inside the bracket, we actually shift to the left, since everything is happening 45 degrees earlier. So it happens before 180. The 3 outside the cos here at the front adjusts the amplitude of the wave, giving us our minimum turning point at -3 and our horizontal component to be 135. Cool. Question 14. Solve the equation x over 2 minus 1 is equal to 3 minus x over 5. Oh, awesome. We've got x's on both sides. So to solve the equation, we need to figure out what 1x is equal to. So what we have is x over 2 minus 1 equals 3 minus x over 5. Let's get rid of the fractions first. Lowest common multiple of 2 and 5 is 10. I'm going to multiply everything by 10. Okay, so that gives me 5x minus 10 is equal to 6 minus 2x. Do you want let's put the line of working in between that so everyone can see where we got that. If we multiply through by 10, we get 10x over 2 minus 10 is equal to 10 brackets 3 minus x all over 5. So that becomes 5, that becomes 1, that becomes 2, that becomes 1. Break those brackets, 2 times 3 is 6, 2 times x is 2x. Hopefully that's sorted out how we get there for you. All right, so now gather our terms. We've got 5x plus 2x is equal to 6 plus 10. So 7x is equal to 16. giving us then that x is equal to 16 over 7. Woo! We can go back and check that, though it would be quite a complicated one to check. Just pop the number back in for x. Alright, last question on the paper. A ball is kicked from a cliff top. The height, h meters of the ball relative to the cliff top after t seconds is given by h equals 12t minus 5t squared. Calculate the height of the ball above the cliff top after 2 seconds. So I'm going to make this question a little bit smaller so I can fit it all onto the page here. I'm going to write over to this side. So h equals 12t minus 5t squared. We want t equal to 2. So h is equal to 12 times 2 minus 5 times 2 squared. So h is equal to 24 minus 4 times 5 is 20. So that gives us negative 4. Oh, no, sorry, positive 4. I'm having a moment there. 4, and so that's 4 meters above. Above has a V in it, a B in it. Above cliff top. Okay, so carrying on, the graph shows, the graph below represents the height h meters of the ball relative to the cliff top after t seconds. The C is 17 meters below the cliff top. After how many seconds will the ball hit the C? So this time we want the values for t, where h equals negative 17. So if we grab our formula again, I'm just going to sneakily grab it from here so that I can scroll down. So we want the values of t when h equals 17. So what we need to do is rearrange this for t. So I'm going to say that 12t minus 5t squared is equal to negative 17. Let's rearrange that again. I'm actually going to pull this stuff over to that side to give me, taking that over, it becomes a plus. I'm going to get 5t squared minus 12t minus 17 equals 0. So let's take that over, it becomes a minus, and leave that where it is, and then just swap sides. So now I've got 5t squared minus 12t equals 17. Minus 17 equals 0. So that is a trinomial that we can factorize, equal to 0. So factors of 5 are 1 and 5, so we're going to have 5t and t. And a negative here implies that we're going to have a positive and a negative in our brackets, with the larger of the two numbers being a negative. So odds are the larger number is going to multiply by the 5, so it's going to be in this bracket. So what we want is the factors of 17, which is a prime number, so that makes it a little bit easier, 1 and 17. And we want to multiply one of them by 5. And then we want to combine them in such a way that we get negative 12. So 117, 117, 117, 117. So what I'm doing here is I'm going to have the positive negative rearrangement, and times by 5, times by 5, times by 5, and times by 5. And what we want is the combination of these that gives us negative 12. So negative 1 times 5 is negative 5 plus 17 is 12. So it's probably going to be the reverse of that. I think that's going to be 5 plus negative 17 is negative 12. So we know it's going to be this one. So we want a positive 1 times by 5, so plus 1, and a negative 17 in here. With that in mind, we get then that 5t minus 17 equals 0, or t plus 1 equals 0. Now we can ignore this one because t equals negative 1, ignore negative time, because it can't hit the ocean floor before it was kicked, or the ocean surface before it was kicked. So going back to this then, 5t minus 17 equals 0, so 5t equals positive 17, giving us then that t is 17 over 5. And we can leave it like that as that fraction, or we could, 17 is 34 over 10, which is 3.4. You know, I'll write in how I did that there, just so you've got it. So that's 34 over 10. Just doubling both, giving us 3.4 seconds. Like I said, you could leave that as 17 over 5 if you want to. That's just a thought there, since the fraction is quite nice and easy for it. So we get 17 over 5 seconds. Make sure your seconds look nice and distinct from your fives. Okay, and that is the end of the question paper. So we're going to have a look at paper 2 in the next video. And a nice big thank you to E3N5R, who have kindly sat very quietly through the whole of this video. Thanks very much. Goodbye.